Dear students, the history of physics can be divided into two eras. Classical physics, the physics up to 19th century. Modern physics, the physics of 20th century. Classical physics is based on laws of Newtonian mechanics. The great success of Newton theory was the formulation of diverse scientific observation into certain specific set of laws. Throughout the 19th century, a steady progress was made in the field of classical physics. Faraday, Coulomb, Oersted, Ampere, Ohm, and Henry established the relation between electricity and magnetism. Faraday gave the idea of lines of forces around magnetized and charged bodies. Clerk Maxwell gave mathematical language to these idea of lines of forces. The idea of electromagnetic waves emerged out of these Maxwell equations, which were later on confirmed by Hertz. In the beginning of 20th century, a series of new experiments was performed whose results and explanation shattered the whole basic principle of classical physics. Michelson and Morley, Schrödinger, de Broglie, Bohr, Heisenberg, and Einstein challenged the old ideas of classical physics. Maxwell still believed that electromagnetic waves require certain medium for their propagation. Ether was supposed to be a medium which is filled in all the universe. Earth is moving through space at a speed of 30 km per second. Even if we suppose that ether is at rest, we should expect ether winds on the Earth. Michelson and Morley, using their interferometer, tried to find out ether winds on the Earth, but the results were negative. Modern physics buried the idea of ether theory. Another logical result was that speed of light is a universal constant irrespective of the motion of source of sound or the observer. A rich person of poor society may be poor person of rich society. So poor and rich are relative terms. Beauty is also a relative term. A person may be beautiful for me, but not for you. And a person may be beautiful for you, not for me. An ugly child is the most beautiful kid of the earth for the mother. Beauty lies in the eyes of observer. So relative terms are those which depend on others. Absolute terms are those which do not depend on others. Motion and rest are relative. How do you define motion? A body is said to be in the state of motion if it changes its position with respect to surrounding. Look here. Which one is moving? Of course, this one. How do you know this? Because it is changing its position with respect to surrounding. If there is no surrounding, then you will not be able to tell which one is moving. We have many examples of relative motion in everyday life. Suppose you are sitting in a train. You are at rest with respect to observer inside the train. But you are in the state of motion for an observer outside the train. We take another example. Suppose two cars are moving on the same straight line, one with greater velocity and other with slower velocity. The driver of the fast moving car will observe that the other car has moved in the backward direction. The driver of the slow moving car will observe that the other car has moved in the forward direction. An observer standing by the road will observe that both the cars are moving in the forward direction, one with greater velocity and other with slower velocity. Same phenomena is observed by three different observers differently. While observing through the window of a moving train, you observe that trees and houses are running backward, an observation against reality. When a nearby train starts moving, you think that your train has started moving. You say hello to your friends, and your friend says, you have gone out of mind. So all motions are relative. There is no such thing as absolute motion and absolute rest. If you want to find out the absolute motion of a body, then you must have a body at rest in the universe. And I am sorry to say that there is no body in the universe which is at rest. It is because of this reason that whenever you want to find out the velocity of a body, you have to mention the frame of reference with respect to which you are finding that velocity. Suppose m0 is the rest mass of an object which is placed in a moving frame of reference. V is the velocity of the frame of reference, c is velocity of light, and m is the mass of the same object as observed by an observer outside the frame of reference. Then according to Einstein's result, m is equal to m0 under root 1 minus v square over c square. Now suppose our frame of reference gains velocity of light, then v is equal to c. Putting v is equal to c here, we will have under root 1 minus v square over c square is equal to under root of 1 minus c square over c square. Now c square over c square is equal to 1, therefore we will have the value of this factor is equal to 0. Now putting the value of this factor here is equal to 0, we will get m is equal to, here you can see m is equal to m0 over 0. Anything divided by 0 is equal to infinity. Now by Newton's second law of motion, we have F is equal to ma. Putting m is equal to infinity here, we get F is equal to infinity. This means that infinite force is required for our spaceship to gain velocity equal to velocity of light. Since infinite force cannot be applied, so we conclude that we cannot give a body velocity equal to velocity of light. Dear students, are you not worried about the results? Up to now, you have studied that mass is a constant quantity. Now we are saying that it changes with velocity of the object. I will further surprise you by saying that this increase in mass is not for an observer inside the frame of reference. This increase in mass is for an observer outside the frame of reference. The Earth is moving through the space at a speed of 30 km per second. This means that this is the maximum velocity we have achieved for an ordinary body. This velocity is very small as compared to velocity of light. So the factor v square over c square is approximately equal to 0. And the value of the denominator under root 1 minus v square over c square is equal to 1 minus 0 is equal to 1. Putting this value in the above equation, we have m is equal to m0. This means that we do not observe any variation in mass in the bodies of everyday life. This is applicable to only subatomic particles. And one thing more. Has the law of conservation of mass been violated in this case? The answer is no. The energy we have given to the body to gain the velocity near to velocity of light, the part of that energy is converted into mass according to the equation E is equal to mc square. Suppose L0 is the length of a rocket at its launching pad. V is the velocity of the rocket and c is the velocity of light. L is the length of the rocket when it is moving with this velocity v. You have just studied that when this velocity v approaches near to velocity of light, the value of this factor decreases. When the value of this factor decreases, the value of L decreases. This phenomenon is known as length contraction. Suppose T0 is the time of an event measured by an observer inside a moving frame of reference. V is the velocity of the moving frame of reference, and t is the time of the same event as observed by an observer outside the moving frame of reference. When the velocity v approaches near to velocity of light, the value of this factor decreases and hence the value of t will increase. This phenomenon is known as time dilation. Dear students, we have many things to surprise you today. Visualize a situation in which a person fires a bullet at the other person in a moving frame of reference. The person inside has died. But for an observer outside the moving frame of reference, the bullet is moving in slow motion and the person who is actually died is still standing over there at that moment. If you have not got the idea, let me explain it to you with another example. Let you have two twins. One is on the earth and other is moving in a spaceship with a velocity near to velocity of light. Time will dilate for both of them. After suppose 80 years, the spaceship comes back to earth. The twin in the spaceship will think that his brother has become an old man of 80 years, and the twin on the earth will think that he is still a child, but his brother in the spaceship has become an old man of 80 years. A dilemma which will never be able to solve until our spaceship can get the velocity near to velocity of light. Modern physics has completely changed the idea of time and space. Neither the time nor the space is absolute. As mass and energy are interconvertible, given by equation E is equal to mc square. Similarly, time and space are interconvertible, a difficult idea to understand at this stage. A good absorber of heat is a good emitter, and a bad absorber of heat is a bad emitter. A perfect body, which is capable of absorbing all the heat radiation falling on it, is not possible. But the nearest approach to this is a cavity radiator. It is a solid that has a hollow cavity within it. It is just like a little oven, which is so designed that any radiation entering it bounces back and forth many times before it leaves through the small hole in it. Look at the spectrum of heat radiation emitted by a black body radiator. This is the experimental curve. Many scientists try to explain this experimental curve. Wien's curve agree in the shorter wavelength range but disagree in the longer wavelength range. You can see it cuts the wavelength axis at this point. Rayleigh-Jean curves agree in the longer wavelength range but disagree in the shorter wavelength range. When ultraviolet light is made to fall on cathode, electrons are emitted. These electrons are repelled by a negatively charged cathode and attracted by a positively charged anode. A current flows through the circuit. These electrons are known as photoelectrons. This current is known as photoelectric current, and this phenomenon is known as photoelectric effect. Dear students, the results of photoelectric effect cannot be explained on the basis of classical physics. The results are: no photoelectrons are emitted, how intense the light may be, if the frequency of falling light is less than a critical frequency called threshold frequency. Number 2, photoelectrons are emitted, how weak the light may be, if the frequency of falling light is greater than threshold frequency. Number 3, threshold frequency depends upon the nature of the metal. Number 4, the number of photoelectrons depends upon the intensity of falling light and not on the frequency. And number 5, the energy of photoelectrons depends upon the frequency of falling light and not on the intensity. Dear students, we are in a very difficult position here. We cannot understand that why an intense beam of light cannot cause emission of photoelectrons, and why a weak beam of light can cause emission of photoelectrons if its frequency is greater than threshold frequency. Classical physics cannot solve this problem, because according to classical physics, light is continuous. That means light is providing energy continuously to electron, and when electron gets sufficient energy, then it should come out. Einstein took the idea of Max Planck and said that not only heat radiations but all electromagnetic waves consist of packets of energy. Now we can explain photoelectric effect on the basis of this theory. Photon is considered as a particle It is a case of particle-particle collision. If photon has got energy greater than the work function of the electron, that is the energy required by electron to come out, then photon will transfer all of its energy to electron and the electron will come out. On the other hand, if photon has energy less than the work function of the electron, then photon will transfer no energy at all and the electron will never come out.
Dear students, Einstein gave the idea of photon model for photoelectric effect in 1905. Compton in 1924 confirmed the existence of photon model for photoelectric effect by a direct method. If a photon is particle, then it should behave like a ball which strikes another ball. First ball is just like an incident photon, and another ball is like a bound electron, which can be treated as a free electron. Suppose if there is a collision of two balls, then one ball gives a part of its energy to the target ball and has scattered with the remaining energy. Now, look at this photon. It has energy E is equal to hf. It strikes with the target electron, gives a part of its energy to electron and scatters with the remaining energy E, which is equal to hf prime. The scattered electromagnetic radiation has frequency f prime, which is less than incident frequency f. The phenomenon is known as Compton effect. You might be thinking that Compton effect contradicts the photoelectric effect. In photoelectric effect, a photon transfers all of its energy to electron or does not transfer any energy at all. In this case, we use ultraviolet light, whose photons have energy slightly greater than the energy needed by an electron to come out of the atom. Compton used X-ray photon of energy of about 17.5 kilo-electron volt, which is much greater than the work function of target material like graphite. Such a high energy photon can transfer a part of its energy to electron and can scatter with the remaining energy. In photoelectric effect, a photon transfers all of its energy to electron, and in Compton effect, a photon transfers a part of its energy to electron. Another way by which a photon can transfer its energy to matter is pair production. When a photon strikes a nucleus, it is disintegrated into two material particles, an electron and positron. Electron is a well-known particle to you. What is a positron? Its charge and mass is equal to electron, but the nature of its charge is positive. We call it as an antiparticle of electron. Now the question arises that what is the role of this nucleus? The role of nucleus in this process is just to share some energy and momentum in order to conserve the two quantities. The rest mass energy of electron is m0 c square, and that of positron is also m0 c square. So, the total rest mass energy of photon for disintegration should be 2m0 c square, which is equivalent to 1.02 million electron volt. If the incident photon has energy greater than 2m0 c square, then the extra energy is taken away by the pair as kinetic energy. So, the equation is hf, which is equal to 2m0 c square plus kinetic energy of electron plus kinetic energy of positron. The reverse is also possible. When an electron and positron recombine two photons, each having at least 0.5 million electron volt energy are produced and move in opposite direction in order to conserve momentum. Dear students, you have just studied that a positron has mass equal to electron. Its charge is also equal to electron, but positive in nature. So, we call it as an antiparticle of electron. In 1933, Anderson observed this particle experimentally during the study of secondary cosmic rays. In 1955, antiproton, and in 1956, antineutron was discovered in cosmic rays. Now, we have very interesting idea in our hand. The building blocks of matter are atoms, which consist of electrons, protons, and neutrons. It is logical to think that the building blocks of antimatter are anti-atoms, consisting of anti-electrons, antiprotons, and antineutrons. This prediction of antimatter was made theoretically by Dirac in 1928. Now, the question arises that where is antimatter? Matter is present in this universe and antimatter is present somewhere in the anti-universe. Dear students, there is no room for thought stories in sciences, but sometimes these thoughts lead us to the hard facts of life. It was all energy before the creation of this universe. Then, in the presence of some nucleus, the nature of which is not known yet, universe and anti-universe were created. They both moved away from each other as electron and positron. When they will recombine, the energy will be produced again. That might be the day of judgment. Only the nucleus will remain. Guess, what is that nucleus? It is believed by scientists that everything has reverse in the anti-universe. Visualize this interesting situation. At this moment, an anti-Sima delivering a lecture in the same words to the anti-viewers just like you. Do you like to meet your auntie? Don't do it. Explosion will take place and energy will be the product. There is another theory. When millions of electrons and anti-electrons recombine together, then an extra electron is left behind. So is the case with proton and neutrons. Universe and anti-universe has already recombined. This vast universe, which is beyond imagination, is the result of this extra mass. De Broglie, in 1923, argued that if waves can act like particles, then particles should act like waves. A particle is neither truly a particle nor truly a wave. A wave is neither truly a wave nor truly a particle. This is what we mean by wave-particle duality.
Dear students, just recall what you have studied today. Theory of relativity and its important results. Idea of photon from black body radiation. Photoelectric effect, Compton effect, pair production, wave-particle duality, a subject on which you can think more. Thank you for watching. Khuda.